All right, so today we're going to talk about the natural base, which is base E. Remember that when you just see a log of something and you don't see a base in there, that base is base 10. Okay, so that was something that we've done throughout the whole chapter. This is the new stuff. So now when you see natural log of x, the implied base is actually E. And even though it's ln, the way that you say it is you say natural log. All right, so what is E? E is an irrational number. And you're kind of familiar with an irrational number like the number pi. Pi is approximately 3.1415 and so on. It goes on forever. Well, just like that, E is approximately 2.718 ... Now you can find this button on your calculator. So if you go to your calculator, there's two places where you can find it. Second, and then the division key. That'll give you E, and you could see a decimal approximation for E. The other place you could find it is if you hit second and then natural log. And that'll actually set up for you to do E raised to some power, and then you could put in whatever power. So if I wanted to raise to the second power, or E to the first power, and so on. All right, this will just give you regular E. Okay, so we're going to do a whole bunch of different problems involving E, and we'll go through more details as we get to those problems. So first thing is we're going to graph. So in number 1, you're going to go to y equals, you're going to do e to the x. Now, I did second divide, but you could also do second natural log, so you could do e to the x that way. If you do it that way, make sure you close the parentheses. Okay, because the only thing that should be up in the exponent is the x, not the plus 2. So type it in, you're going to hit graph. All right, so something that you need to know is that you're going to have an asymptote, which is like that wall that your graph gets really, really close to, but never touches. So this tells me that I'm going to have an asymptote at y equals 2. So that's like my imaginary line. It's horizontal because it's y equals. And my graph is going to get really, really close to it, but it's never going to touch it. You could tell from the curve that that's what it looks like. If I go to my table, I'm going to just find a couple of nice points to plot. So I see I've got 0, 3. You probably won't find too much in terms of whole numbers, so we'll just do -4, 2.02, -1, 2.37, 1, 4.7, and 2, 9.4. All right, so we've got -4, go up about 2, a little bit above 2. -1 would go 2.37, 0, 3, 1, and 4.7, and then 2 is 9.4. So I'm going to connect those points and make sure it looks like what you have on your paper, or your paper looks like what you have on your calculator. All right, and then notice that this never touches my asymptote, it just gets really, really close to it. All right, problem number 2, we're going to do exactly the same thing. So we're going to type it in. We've got e raised to the 2 minus x. So we do actually want the whole thing up in the exponent. Okay, hit graph. And then this time there's nothing being added at the end, so my asymptote is at y equals 0. So that tells me that I have a horizontal line at the x-axis that my graph is going to get really, really close to, but not actually touch. And then I'm going to come up with a table of values so I can plot a few points. All right, so these numbers are way too big to fit on my graph. So I've got 0, 7.39, 1, 2.72, 2, 1, and then I'll skip, let's say, to 4, 0.14. All right, so 0, we're at 1, 2, 3, 4, 5, 6, 7, a little bit above. And then 1, 2.72, 2, 1, and 4, and 0.1. All right, so if you look at your graph, make sure that you draw on your paper what shows up on your calculator? All right, so it goes up forever and it gets infinitely closer to our asymptote. All right, when you're ready, flip to the other side. All right, so now these ask you to simplify. So a lot of these simplifying problems involve rules that we used earlier in the chapter with basic logarithms. So if you remember, a log and natural log, those are the same thing. You just have to know what your base is. So when you see natural log, remember your base is e. This is not my base. I'm going to put in a base right here. So it's really log base e of e to the 7x. So remember, anytime you see an exponent, you can put it out in front. So 7x times natural log of base e of e. Okay, so this we should remember, if we have a log that has the same base as the number that we're taking the log of, these cancel out and this equals 1. So this is just 7x times 1, which is just 7x. Okay, here I have e to the 3 times natural log of x. So I'm going to put in a little e here. That'll remind you that you have a base e. Okay, so first thing we're going to do is this 3 is going to move to be an exponent. So I have e to the natural log, that's base e of x, cubed. All right, so then this is one of our shortcut rules. If we have e to the log base e, those cancel out, so the only thing that's left is x cubed. All right, here again I have a coefficient. This needs to move to be my exponent. Actually, no, let's not do it that way, because that might be confusing since there already is one. So we have 2 ln of e to the x. All right, so I'm going to first fill in my e. All right, this exponent I'm going to move out in front. Now there already was a 2 there, so I'm going to make it 2x. So 2 times x times natural log, which means base e of e. So we know base e of e, that's gone. That's just 1. Right, so the leftover is just 2x. So we could go back and do the problem the other way I was talking about. So here we would square it, right? So then we would do 2 times x. That's natural log of e to the 2x, okay? But then we would just end up moving this out again, so we're just kind of back to where we started. So that's why I didn't really want to do it that way, but in any case, you still get 2x. All right, this one we have e to the natural log of 2x. Don't forget that that's the base e. So if you have e to the log base e, those cancel, and you're just left with 2x. All right, so then yesterday we solved with log equations. These are the same thing. They just have natural log. So I'm going to fill in my base e. All right, our rules from yesterday, if you recall, were to condense if possible. So this is our product rule. And this is our quotient rule. All right, so my product rule says that I should do 6 times x. My quotient rule says I should do 7 divided by x. Okay, so just as a reminder of how to condense. So now what we're going to do is we're going to change these into exponential form. Look at what your base is. Your base is e. So I'm going to rewrite this as e to the natural log base e of 6x equals e to the third. So whatever my base is, make sure you do that on both sides. These things just become your exponents. And then we can cancel out because e and log base e have the same base, so that's just going to leave us with 6x. Now for e to the third, you could use your calculator. So e to the third power. We're going to round to 3 decimal places to 20.086. And then I need to divide by 6. And I get x equals 3.348. All right, last problem. We already started it by condensing, right? So we used our quotient rule. Then we look at what's our base. It's e. So it's e to the natural log base e of 7 over x equals e squared. These become my exponents. My base is e. So remember, the e and log base e, they cancel. So I'm left with 7 over x equals e squared. Now what is e squared? Use your calculator. E squared is 7.389. All right, so now I just need to solve for x. So to do that, I'm going to get rid of my divide by x by multiplying. So I have 7 equals 7.389x. Then I'm going to divide both sides. So I've got 7 divided by this number. I'm just going to take my answer. So that gives me 0.947. And then you're all done.